Hello, welcome back. Today let's try to solve another Leetcode problem, 1615, maximal network rank. So this is from the Leetcode daily challenge. Let's read a little bit about the problem, and then I'm gonna explain it a bit, and then I will try to finish it in the code editor. So for the description, we know that this is a graph problem, and we have nodes. They are vertices. So the vertices is from 0 to 3, but we have 4 nodes. It means it will start from 0 to n minus 1. So it means we have n vertices. And inside the rows, it means the ends of the graph, they are connected from 0 to 1, they are connected bidirectionally, because here said it is a bidirectional road between AI and BI. And also, we need to return the rank. So what is the rank? Let's see the definition of the rank. So the maximum network rank of the infrastructure is the maximum network rank of all pairs of different cities. This means that we have to use the brute force to check all pairs. For example, let's check the rank of 0 and 2. So for 0, there are 2 ads connected to 0, and for 2, there's only 1 ads connected to 2, so the rank is 3. But that is not the result. The result is the maximum. For example, if it is 1 connected to 2, 0, and 3. So there are 3 ads. And for example, there's another number 3. There's another ad from 0 connected to 3. So it is 1. 1 plus 3, it is 4. Or we can also choose the 0 and 1 pair. If we choose the 0 and 1 pair, for 1, there are 3 ads connected. For 0, there's another ad connected to 3. So the final result is 4. So how should we approach this kind of a problem? Normally, we need to check the situations. We need to, go through all pairs. Let me write a little bit. If we are going to go through all pairs, let's check U. For U in range of n, because U will start from 0. We're gonna include this 0 node. And for V in range will start from U plus 1 to n. Because this is the brute force to check all pairs of the node. If 2 notices are connected, it means it becomes an ad. We need to do some tricks to calculate it. Let's check if they are not connected. For example, this 2 and 3. They are not connected directly. For 2, there's 1 ad. For 3, there are 2 ads. So there's no duplicate. We just need to use 1 plus 2. If we are going to use a pair, for example, 1 and 2, they are a pair. For 2, there's 1 ad. For 1, there are 1, 2, 3 ads. But for 1 and 2, 2 and 1, they are duplicate. We need to minus 1. So this is the only trick for this graph problem. As you can see, we just need to check 2 different situations. So how should we check? How should we check if this ad is inside, whether this 2 and 3 combined become a pair of ads, like directly connected, like 1 and 2 directly connected, or 2 and 3 not directly connected. We can directly use a set. What are we going to do? We just put those ads connected 0, 1, and 1, 0, put all those pairs inside a set. Then we just need to check if 2 and 3 is inside the set or not. If inside the set, we're gonna, it means a direct add. It means we just need to plus this connected numbers and this one connected numbers minus 1. If it is not, we just need to plus this 2 plus this 1. Now let me just do it as our graph problem. For this problem, we are giving a network of graphs, so I'm gonna use a adjacency list to apply this graph problem. So for the adjacency list, it will be default, dict, and list. I'm also going to use a set, as I explained, because I'm going to check if the pair of nodes is a direct adds or not. So it will be a set. And finally, I'm going to have a result as my maximum rank. So the result will start from 0, because even if I have 2 nodes, they are not connected. For example, 2 and 3, I only have 2 nodes. I I don't have 0 and 1. I only have 2 and 3, and they are not connected. So it will return a 0 because here n will be more than or equal to 2. So this means, yeah, for the result, it will have a minimum of 0 because finally, I'm going to return my result. Now let's do something, do some preparations for the graph. We just need to use a loop. So for u v in road, yeah, so for those edges in the road, we just need to use j u dot append v. We put it inside the adjacency list, and similarly, we need to put the u inside v, yeah, inside the adjacency list. So the jv should append the u. So now we prepared our adjacency list of the graph. Yeah, there are normally two. One is adjacency list, another is adjacency matrix. But for us, we should use the adjacency list to solve the problem because it's easier and it is just a sparse graph. Yeah, and it's easier to check. Why? Because we just need to check how many nodes directly connected to it. We don't need to define a adjacency matrix. It really takes time to calculate how many. Yeah, basically it's the same, but adjacency list is easier because after that I just need to check the length of the list. For example, 1 is connected to 0, 2, and 3. I just need to check the length of the list. I will get my result. I don't need to do any calculations. And for length of the list, it is just O1 calculation. That is why it is so fast. Yeah, now let me just put it inside the set. So s dot add a tuple of u and v, and because it is bidirectionally, I should also add the v and u. Now I finished the definition of my set and graph. After that, I'm gonna check. So for u inside the range, for v inside the range u plus 1 to n. So this is basically brute force. I just need to check if the tuple of uv inside the set or not. If it is inside the set, so the result will be max of result with a length of, let's say, gu, and plus length of graph of v, the v node, if it is inside, but we need to plus 1 as well, because if it is a pair, we need to, minus 1. If it is a pair, we need to minus 1, as I explained earlier. If 1 and 2 as a pair, we counted 1, 2, and counted 2, 1. So we counted it twice. That is why we need to minus 1. Else, we don't need to minus 1. So the result should equal to, let me copy it from here and delete the minus 1. Because if they are not directly connected like 2 and 3, we don't have duplicate, so we don't need to. Let's check the time complexity. So this is u inside n, v inside n, that is On. But for here, inside the set, it is just O1. And for the result, for the length, it is just O1. So in total, it is On squared time complexity. So that is why it's so fast by using adjacency list. Yeah, as you can see, it works. Now let me submit it to check if it can pass all the testing cases. As you can see, it passed all the testing cases and it's pretty fast. Thank you for watching. If you think this is helpful, please like and subscribe. I will upload more Leetcode problems like this. See you next time.